Hello, I've bought one of the Arturia Micro Freaks and I really like it. It's just a small tiny little thing that you can use for all sorts of quirky, weird, strange sounds. Yeah, and I'm having a lot of fun with it, and I don't actually mind this keyboard. This keyboard's quite nice once you sort of get the hang of it. It's very quick and very responsive. However, this is not a review video, and I'm not going to demonstrate sounds and things like that. What I'm going to do is I want to open this up, have a look inside there, and see if there's actually enough room to build some sort of power pack inside this. You can already plug one of these power banks into it and just plug directly into the USB input, because this will work directly off the USB input. You don't have to use the 12-volt adapter that comes with it. So it will work on that, but that's another thing that you've got to have hanging about with a cable attached. And I kind of think it would be nice if it was all actually just built in there, so you could just turn it on and use it. So I'm going to open this up and have a look inside first. So I've taken out all the screws in the bottom, and everything is kind of movable. It's coming up. I'm just being a bit gentle with it, actually. It will come up. There we go. And immediately there's a sort of a ribbon cable there, so I'll have to disconnect that ribbon cable. There we go, and that releases that piece. Just get the keyboard up. That one's a bit fiddly. Haha. So it looks like there might be some space to play about with inside there. So yeah, there's the little keyboard, and what it basically is the black keys is one circuit board with the buttons and the bender control here, and the white keys is another circuit board, and one of them is sort of stuck down on top of the other, and that's what gives the black keys a little bit of a raised edge as well. So yeah, so there's two circuit boards sandwiched together there, and then there's another circuit board on the bottom, and this looks like it's got a little ARM processor and quite a few multiplexer, demultiplexers on there. So yeah, it's simple enough sort of keyboard that is. Now I think this is so nice because, like I say, I really do like this keyboard. I wonder if Arturia could kind of make a 49 key just MIDI keyboard or something, but like that, so it would be really thin and you could just pop it on your desk and use it as a keyboard for your computer. I think that would be really nice. So the idea is to figure out how much space have I got in here to put a battery. So you kind of look at the circuitry here, and yeah, it's a double board circuitry, but it looks like there's a bit of a gap there. If you look down the side there, there's a bit of space there. So maybe when this is back in here, let's slot that back in there again, maybe there's a bit of a space underneath here to put a battery. Now these are not going to fit, obviously. Even if I knock that out of there, this is what's actually inside one of these, and it's just a 18650 battery with the little simple charging circuit on there. So even if I take it out of that and I put the battery in there, I bet you no way is this going to actually fit. This is not going to go down. No, it's just sort of, it's rocking there because the battery is just slightly too big. That's a shame. But then that's just one little battery. I don't know how long this would even work on that. That's going to be even bigger. But the other idea, like, is going to have to be one of these flat pack batteries. So if I could build one of those in there, will that close down? Oh yes, easy peasy. Look at that. You can hear it rolling around. There's so much space in there. The other thing is, of course, if you're charging one of these, then it doesn't actually give the 5 volts out. I'll show you what I mean. if I'm charging this, like so, little LEDs on there, and I plug in this into here, switch it on, nothing, no power. There isn't a button on here to activate this either. No power. However, if I switch that off, if I pull the charge out of that and then switch it on, then you've got power. And that will drive this for a few hours. But it's like you can't charge it and use it at the same time. So that's why you would need some sort of switching thing if you're going to use the USB on here. It starts to make things a little bit complicated. But yeah, that will work on that. No problem. For, I think I ran it for nearly 3 hours. So I can't charge it and use it at the same time. It's one or the other. So therefore I would need some sort of switch to switch so that this either charges the battery or it powers the actual synthesizer. So we've already seen the keyboard and things. I want to have a little bit more in-depth look inside this bit. Now I've noticed on the board it says Nano Brute, and even on the back of the keyboard I think it said something different. Let me just take the keyboard back up again. Nano Wave keyboard controller. These little ribbon controllers, these little ribbon connectors here, if they've got that sort of dark piece there, that's a kind of a flap. So if you lift that flap like so, you see it's hinged, then you can slide that out and you don't have to force it in and risk breaking the ribbon connector. This is just curiosity really, just having a look inside here, because all I really need to know is how much space I've got to put a battery. And some people might just say, well, what's the point? You might as well just use one of these with a USB lead. Yeah, I know, I could do, but it's a case of, well, if I can build a battery system inside it, why not? So let me lift that up. I'm guessing this is the entire system. So that's why I have to get my glasses on. Getting old now. So we've got STM32F446 ARM processor here. I don't know what this little guy is here. Is that the clock in there? No, that's MIDI. No, this is all for the MIDI stuff. Of course, there's a little opto coupler for the MIDI, opto isolator rather. Yeah, and this is all your power this side. So I've got to try and find out where I can get 5 volts off this to charge the battery and to bring 5 volts back to it again, and maybe make a switch so it actually disconnects the 5 volts coming in here so it can go off and charge the battery instead of run the system. So there you go, there's the main board. Isn't that sweet? Just take these screws out of here, and then this piece here for the OLED, that's going to be another one of those that you lift up. So the circuit board is kind of almost free to move, except it looks like, yeah, the little circuit board for the OLED is actually glued into place, so that doesn't come off with the unit here. Ta-da! Oh, there's another ARM chip there. It's actually 2. There's an ARM2 STM32F030 there. I can't even read that. 32F030 there as well. Yeah, a couple more little ARM processor things there. Other than that, it's all just little surface mount LEDs, obviously, for the matrices and things like that. And just your switches. So yeah, not a lot to see on there, which is probably why they can make it so cheap. So yeah, that is your whole synthesizer. Wow, isn't that beautiful? Now, if you go taking yours apart and destroying it, I'm sorry to say that's your problem. And do realise that if you open up one of these within the first year of purchase, then you are going to void your guarantee. Now these little things here or bloody awkward to get in. There, gotcha. All I need to do is get the switch in. That way I can just say charge that way or feed back to the machine that way. And that would be like selecting the charge going in or the power coming back out again. So basically, these 4 little connections here, this is coming off the USB just there. Now, not absolutely sure, but I'm guessing this one's going to be the negative and this one's going to be the positive. I'm kind of guessing because I had a look at it with the multimeter earlier and I think it's that way around. And these two on this side will be the data plus and data minus. So I've got the big USB connection like so. That has 4 connections inside it: positive, negative, data plus, data minus. And then I've got the small charging socket. I'll do it like so. They normally have 5 in. One of them isn't used. I think it's that one. And then I'm going to have a switch, and that's got 3 pins on. I connect the positive to the center pin there, and then come out of one of them into the big USB and one of them into the little USB, that's the connections. Then I should be able to flip the switch so that when I plug into the USB on there and give it 5 volts, I should be able to flip the switch and it will feed the charging circuit. When I unplug it and flick the switch the other way, then it should give me 5 volts back again, therefore running the unit off the battery pack that's inside it. Yay, nay? Oh, what the hell, let's go for it. Now I've just had a thought. If I put this in so it either charges it through the USB port or feeds back into the system, the power coming back out again, that means every time I'm running this on the USB, on a computer or even a little laptop or something, it's going to have to be feeding the actual synthesizer and charging this at the same time. So that's going to be drawing quite a bit of current, especially if you're running it off a little laptop or something. So I've changed my mind and I'm kind of going to use this one. This one is a center off. So that way, if I'm running this on a laptop and they don't really give out much power, that way I can flip this in the center and the USB input will feed the synthesizer, but will not be charging this as well at the same time, type of thing. Therefore, that will be completely eliminating this and this circuitry and everything from a laptop. Because having that so it's always charging when I've got it plugged into the USB is not really a good idea, because the whole thing is drawing too much power then. So that is the switch I'm going to use. So that will be to charge it and run the machine. That will be to completely isolate this from everything else. And that will be to give the power back to run this when you're not using the USB. I don't know if that makes any sense, but yeah, it should all come out in the wash, as they say. So I've got to carefully try and mark the center line and get that in the middle there, because I know, because of this circuit board, there is space for this to just float about there, which is about midway, and it shouldn't be sort of touching anything on the board. There's just enough room for it to sit in there. So I'm going to do this by eye, really, just sort of get it about center-ish. Would you say that's about middle? I think so. There we go. Brilliant. I can't actually put this switch in yet anyway. I've got to put the board back in first and then put the switch in and then put the top board on. So I'll start reassembling it now. Now the problem is, will all this actually fit? Of course you will. I hope. Please fit. Please. Oh. It fits. Look at that. Yes. Yes, it still works. I can't believe I haven't destroyed this yet. Alright, now the fun begins. Trying to solder all this up. So, I'm going to use a bit of the rainbow ribbon cable, just to try and keep the wires as neatly as possible, because it's going to look a little bit of a mess, I'm sure. As long as the outside of it looks good. Just a little bit of this Capcom. I can never pronounce what this tape is. Capton tape or Capcom tape. I wish somebody would tell me what it is. I really don't know. Now that should be okay. The only reason I'm putting this tape on, really, it doesn't need it on, but if in the future this bolt starts to loosen and the actual switch twists around, then you're in danger of the metal parts touching the circuit board here, and you don't want it sort of touching or shorting out on anything there. So now the difficult part, I've got to get two wires onto the USB connections underneath there. That one's negative, that one's positive, I think. I hope. By heck, I think I've done it. Bit more of the Captain, whatever, tape across there. There you go, that'll do. So I'm going to chop this in the centre. Now I'm just going to use a little bit of circuitry like this. It's just a bit of strip board really, and just get all the wires onto there and just put a bit of tape over. Try and make it as neat as possible. I mean, it's not going to look neat, but anyhow. So if I use what I've got in there, 4 piece of circuit board or strip board with 4 connections on it. So from this side, if I go off for the blue wire, that's the neutral, negative. And so both of these white ones off these 2 connections, so there's the big USB and there's the little USB. That's the power coming out, that's the power going in. So if I put the white one in there and the white one in there, just put a W on it, there you go, that's white, and that leaves me enough for the switch. So there's a little switch, there's your 3 connections in the middle. Right, now I've got to think what I'm doing. Yellow, orange, red. So the orange is the middle one, and that needs to go with the green wire. So right, so basically I need to have the green wire and the orange wire connected. Anyway, yeah, I'm sure it is. So the yellow wire, which is on that side, that's going to have to go into where the power's coming out, because when you flip the switch this way, that will be connecting those 2 that way, so that will be as if you're powering it from the USB device. So the orange wire, so I want that red one going in there, and that one going out to the yellow, and then the red one coming off here is going to go to the red one on there. Yeah, of course it'll work. I'm sure it'll work. Right, I've soldered all those little bits up, as in that bit of description there. And yeah, okay, it looks a little bit of a mess. And I should have really found a nice big piece of heatsink to put over that. But good old black electrical tape comes to the rescue. Look at that. It's like a shop bought one, isn't it? Not. So all I'm going to do here is put a bit of this nice hot snot in the corners here, just to stop this thing from sliding around inside. this isn't brilliant. It won't hold it perfectly into place, but it stops it sliding. That's what's important. Ooh, this is a tight fit, this is. Right. So I've re-hot snotted this in. I put a little bit too much that side and it was pushing against this board here, and that's why I couldn't get the lid down. So, try again. Beautiful. Right. Screw it back together now. Okay. Ta-da! A portable Micro Freak. Yes! So now this is all kind of completed, I'm kind of thinking, was it actually worth doing all that? Because, yeah, okay, I can sort of sit on the bus now and just plug my headphones in and actually operate the thing, which is nice. But you don't really need to do all that. All you have to do really is, if you've got one of these little power banks, just get a cable and plug it in with a power bank and just stick that in there. And that will save you all that faffing about cutting a hole and putting a switch in it. I just kind of wanted to do that just to kind of say, well, yeah, I can make it all fit in there and make it portable with just a set of headphones. But I wouldn't recommend you doing all that work because, like I say, it's not actually necessary. Just get a power bank and plug into the USB and there you go. It's portable already. No need for dismembering your Arturia. So yeah, I kind of did that because I was bored and I wanted to know if it could be done, and yes, it can be done. But anyhow, if you like that video, thanks very much. Please give us a thumbs up and subscribe if you can, and we'll get another video along very shortly. All the best. Bye bye. I'm going to go and sit in the garden now with a pair of headphones and play this. I could get out and about now. Actually, it's really, really hot. I think I'm going to go back in. La la, I'll just go blah 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 because you can't hear what's coming through the headphones.
Yeah. Oh, carry on, you sound
Okay. I can look like a madman now. I'll go and find a bus in a minute. It's almost like an MP3 player. See you later.